All right, folks. For our lesson today, we are going to move on from addition and subtraction of decimals to multiplication of decimals. Now, we talked a lot the last few lessons about the standard algorithm. We won't be doing that again today. We won't be talking about the standard algorithm too much today. We are actually going to use some models to multiply. So I'll show you what that means. It's our Module 1 notes. Module 1, Lesson 11, multiplying decimals using models. All right. Our Roman numeral for 11 is going to be 10 with a 1 after it. 10 plus 1 more. Okay. So we'll go ahead, zoom in a little bit, and take a look. Very little vocab today. Very little vocabulary. In fact, even though it's technically breaking the rules of outlining, only one word. So just one word today. And that word is product. When we talk about a product in math, the product is the answer to a multiplication problem. The answer to a multiplication problem. I think most of us have heard that before. It's not necessarily new, but it is worth reviewing because we will hear it quite a few times today. Okay. Now, let's dive right in to our procedure, although today it will be procedures because there are a couple things I will show you. Not going to really have step-by-step today, so this might look a little bit different. I want to run through a couple of examples with you. We're going to sort of build up as we go. When you're looking in your Learn book, you're going to see things that look like this. Okay, for example, let's do 3 copies of 2/10. Now there are a few different ways that we could show this. Okay. One of the most straightforward would be to create a small place value chart. And please don't feel like you have to make yours quite as neat as this. I know I always say it, but again, everybody's got to stare at mine, so we're going to have straight lines. When you make your place value chart, it's usually easiest to start on the far right with those 3 decimal places: thousandths, hundredths, tenths. Put our decimal here. And then we've got ones, tens, hundreds. That should be fine for this. Okay. Now, we know that this column right here is our tenths column. So if I have 3 copies of 2/10, what I'm going to do is I'm going to draw 2 little circles. The book calls them discs. Okay. We're going to draw 2 little circles. There's my 2/10, right? Well, I'm going to make 3 copies of that. Second copy. Third copy. It's getting a little cramped. 2/10, 3 copies of that. 1, 2, 3 copies, 3 sets of 2/10. If you count those all together, 1, 2, 3, 4, 5, 6, then we see that this is equal to 6/10. Okay? If you want to do it a different way and just use fractions, you'll get the same answer. 2/10, 2/10, 2/10, Put them together, and what have you got? Bippity boppity boo. 6/10. 2, 4, 6. So again, just kind of goes around. Okay. 3 copies of 2/10. Let's do another one. Let's say instead it says 4 thousandths. Slide it up. 4 thousandths times 3. Now I changed the order, but the way that I do this on our number, I keep calling it a number line, our place value chart is not going to change. I start with my chart, make it look nice-ish. Start on the far right, thousandths, hundredths, tenths, decimal point, ones, tens, hundreds. Okay. 4 thousandths. Tenths, hundredths. Here's my thousandths place. So even though the order is flipped, see how we had 3 copies of 2/10 and now we have 4 thousandths times 3? I still want to zero in on this part. I want to find the unit, find the place value column. 2/10, I drew 2/10. 4 thousandths, 1, 2, 3, 4. The first time I went across, this time I'm going down. It really doesn't matter. I'm just thinking ahead and realizing I have to do that 3 times. Times 3. 1, 2, 3, 4. 1, 2, 3, 4. There's my 4 thousandths 3 times. Count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 little thousandths. Now, that in itself could be your answer. However, we didn't have to do it with this one. With 12 thousandths, I cannot put 12 in here. This 1 right here is going to bump over into the hundredths column. There's that 1. Because every 10 thousandths I can group together is the same as 1/100th. And then I just put the 2 there. Okay. Now this is pretty straightforward if we're just talking about how many thousandths you have, how many tenths you have, something like that. But let's say we have a slightly bigger decimal that we're trying to multiply. Okay. If we have a slightly bigger decimal we're trying to multiply, let's say something like this. 7 times 3 and 12 hundredths. 7 times 3 and 12 hundredths. This time I'm going to use a slightly different type of model. Okay. We are going to use the area model. Now this is kind of like vocabulary, but I didn't put it up top because I don't want to give you the words. I just want to show you what it looks like. When you are finding the area of something, most of what you've done so far, you have been finding the area of rectangles, right? And to find the area of a rectangle, see I didn't use my straight edge, it's going to bother me now. To find the area of a rectangle, you multiply length times width. So if this were 7 and this was 2, 7 times 2, we would get 14. Okay? We are going to do something very similar here. I'm going to put the whole number over here on this side, so we'll make that the width, I guess. But the length, I am going to break up. The whole thing would be 3 and 12 hundredths, but I'm going to write it like this. Okay. 3 ones. So I'm taking just the ones place. 1/10. And finally, 2 hundredths. That's going to stretch out a little bit, but that's okay. What I'm doing is a cross between expanded form and word form. Do you see how I broke this up? 3 ones, 1/10, 2 hundredths. By stretching it out, by breaking it up into each individual piece, now I can multiply, each one by 7. So 7 times 3 is 21 ones, 21 wholes. 7 times 1/10 would just be 7 tenths. Think of these units just as any other kind of unit. If I'm multiplying by the number of highlighters, if I'm multiplying by the number of protractors, it doesn't matter. Ones, tenths, 7 times 2 is 14 hundredths. And again, I'm kind of out of space on that one, so we'll cheat a little bit. We'll abbreviate. Okay. By multiplying each piece, I'm getting a partial product. I'm getting part of a product. I can take these partial products and add them together. 21 plus, now I could write 7 tenths again, but you can kind of see I'm switching over to standard form. Let's write 7 tenths in standard form. 7 tenths. 14 hundredths, those are always a little bit trickier. Let's put the 14. Let's remind ourselves, this is the hundredths. This is the tenths. So the decimal should go here. And we'll put a 0 for the whole number. Now, a lot of you might already be seeing where we're going with this. Okay. I'm going to draw a little arrow. I love drawing my wiggly arrows. And I'm going to line all of these things up so we can add them. 21. Now, remember, there is an invisible decimal point there. I need that invisible decimal point to become visible because I need to add this as well. Build it out, build it out. Line up that decimal, 1, 4. Again, if you have graph paper, makes this a lot easier because everything is nice and orderly. Some of you saw, and we'll do this in a later lesson, if you turn the paper sideways, you've got your columns that way also. Okay. Now that we've got this lined up, most of you felt pretty good about the addition. I'll put some invisible zeros there just for fun, but nothing plus nothing is 4. Nothing plus 7 is 7. 7 plus 1 is 8. Decimal stays in the exact same spot. Drop it straight down. 1 plus nothing is 1. See, that 0 is over a little far. Wish I had graph paper. 2 plus nothing. There's nothing else in that column. So the answer to our original question, 7 times 3 and 12 hundredths, is 21 and 84 hundredths. We can use estimation to check. We'll talk about this more in the next lesson. But if you look at this and say, okay, 7 times just 3, drop the decimal entirely, 7 times 3, that's about 21. Our final answer is more than that because we're multiplying more than that, more than just 3. But we can use estimation to see that we're pretty close. Now, I am going to set up one more of these, and I would like you to finish it up at home. 6 times 4 and 25 hundredths. I will get you started. I'm going to Draw the model. Draw the model. There we go. Okay. The whole number goes on the side. And then break this part into, again, that cross between expanded form, and word form. So this is 4 ones, 2 tenths, 5 hundredths, gets to stretch out all the way over there again. Go ahead and finish this up. Remember, these units are just like any other object. 4 erasers, 4 popsicle sticks. You have a group of 4 popsicle sticks. You have 6 of those groups. What would 6 times 4 be? Go ahead and finish this. You'll get a 3 partial products, I should say. Take those pieces, add them together like we did above, and that will get you your final answer for this one. I'll go ahead and check that when I see your notes. One last note before we wrap up. Those of you who are looking at this and maybe feeling a little frustrated, why are we going to all this trouble? Why are we doing this giant expanded thing? Wouldn't standard notation, standard algorithm, wouldn't the standard algorithm be easier? We'll do that in the next lesson, and it might be. So good luck with this. If you have any questions, as always, ask in class. And that's our lesson for today. Thanks, folks.